Hello everyone, welcome back to my YouTube channel. I am Abhishri A of Sri Venkateshwara College of Engineering, and today I am here with a new topic, and today's topic is additional operations, sparse matrix, double linked list. So initially we will start with the single linked list. Single linked list or singly linked list is a linear collection of nodes where each node has some data and a pointer to the next node in the list. And single linked list is where it stores the address or the data, like basically it's an address of the other or the next linked list or the next node. In singly linked list, what happens is we can only transpose in a single direction. We can't transpose back or we can't come back. It's a single direction transversion takes place. And the main advantage of using the singly linked list over other types is that it requires less memory. Linked list operation. There are various linked list operations that allow us to perform different actions on the linked list. For example, the insertion operation adds a new element to the list. Here's a list of basic linked list operations that we can cover in this article or in this session or in this video. Transversal. Transversal is which access each element of the linked list. And insertion is that here new element is inserted or added up. Deletion what it does is it removes the existing element or it deletes the existing elements. Search is where we find a node in the linked list. Like if we give a element value or a element, it goes into the node and it starts searching. Sort is where it sorts the nodes of the linked list. This is a basic syntax or a program to initialize the transpose. Transversed a linked list. Displaying the content of a linked list is very simple. We keep moving the temp node to the next one and display its content. When temp is null, we know that we have reached the end of the linked list, so we get out of the while loop. To explain this, whatever I said, there is a simple program which I have included here. Just struct node temp and head that equals to head. So printf whatever needs to be printed, like list elements are or whatever we give, while temp not equals to null, it will print whatever the data or which we have given. Temp equals to temp, then next, and the output will be like this. Insert elements to a linked list. Here you can add elements to either the beginning, middle or end of the linked list. So first, insert at the beginning. Allocate memory of a new node, then store data, then change next of new node to point to add. Change head to point the recent create node. So this insert at the beginning thing, I have given a simple example over here. Struct node, new node equals to malloc of size of struct node, and new node data equals 4, new node to next head equals to new node. So this is a very basic program. Insert at the end. Allocate memory of new node, store data, transfers the last data, change next of last node to recently created node. And this is explained in this program, this part of program. insert at the middle, allocate memory and store data for new node, transfers the node just before the required position of the new node, change next pointers to include new node in between. And then again, this is the program for this, whatever I explained. This is delete. So you can delete either from the beginning, end, or particular position. First, delete from beginning. For delete from beginning, it's just we should consider point head to the second node, and this is the programming language of the whatever I said. Delete from the end, transfers the second last element, then change its pointer to null. Struct node temp equals null, while temp is next, then next, not equals to null, temp equals temp to next. This is again the simple program. So now we'll know what is sparse matrix. Now we have come into the sparse matrix topic. So a matrix is a two-dimensional data object made of m rows and n columns, therefore having total m cross n values. If most of the elements of the matrix have zero value, then it is called a sparse matrix. Why do you use sparse matrix instead of a simple matrix? First, storage. There is lesser non-zero elements than zeros, and thus lesser memory can be used to store only those elements. Computing time. Computing time can be saved by logical designing and data structure transversing only non-zero elements. So this is the example for sparse matrix. A sparse matrix by a 2D array leads to wastage of lots of memories, as zero in the matrix are of no use in the most of the cases. So instead of sorting zeros with non-zero elements, we only store non-zero elements. This means storing non-zero elements with triples, row, column, and value. Sparse matrix representation can be done in many ways following our two common representations, that are array representation and linked list representation. So method 1 will start with using arrays. 2D array is used to represent a sparse matrix in which there are three rows named as row, column, value. Row, index of row where non-zero elements is located. Column, index of column where non-zero elements is located, and value of a non-zero element located at index, that is row and column. And this is the example and the explanation, like where and all it is located. Okay. Method 2 is using linked list. In linked list, each node has 4 fields. These 4 fields are defined as row, column, value, next node. Row, index of row where non-zero elements are located, and column, index of column where non-zero elements are located, and value of a non-zero element located at index, row, and column. Next node is the address of the next node. So this is a diagrammatic representation or a block diagram. Now we'll know about the double linked list. So firstly, double linked list. And what is double linked? So first here we will know what is double linked list. A double linked list, DLL, is a special type of linked list in which each node contains a pointer to the previous node as well as the next node of the linked list. And this is the basic block diagram. So this is a representation of double linked list node. It's a simple program. Struct node, int data, then the pointer of the next data in DLL, struct node next, then pointer of the previous node in the DLL, struct node previous, and closed brackets. So here we'll know the advantages of linked list over advantages of double linked list over the single linked list. A double linked list can be transposed in both forward and backward. As I said before, single linked list can only be transposed in a single direction, but here in double linked list we can even transpose it forward as well as backward. So here there is double, like two direction transposed here, like the elements can be transposed in two directions. That can't be happen in the single linked list. The delete operation in double linked list is more efficient if a pointer to the node to be deleted is given. We can quickly insert a new node before a given node. In a singly linked list, to delete a node, a pointer to the previous node is needed. To get this previous node, sometimes the list is transposed. In double linked list, we can get the previous node using the previous pointer. And as usual, if there is some advantage in something, then definitely there would be some disadvantages as well. So now we will know the disadvantages of double linked list over the single linked list. Here in double linked list, every node of the double linked list requires extra space for the previous pointer. It is possible to implement double linked list with a single pointer through C, this and this. All operation requires an extra pointer previous to be maintained. For example, in insertion, we need to modify previous pointers together with the next pointer. For example, in the following function for insertion at different positions, we need one or two extra steps to set the previous pointer. And applications of double linked list. It is used by web browsers for backward and forward navigation of web pages. LRU, which stands for least recently used, or MRU, which stands for mostly recently used, that are constructed using double linked list. Used by various applications to maintain undo or redo functionalities. In operating systems, a double linked list is maintained by thread scheduler to keep the track of processes that are being executed at that time.